Hi everyone, my name's Harriet Ingham and I'm from Home Solutions in our Boulder, Colorado office. And I'm here today to talk about time and motion studies. Now this isn't a new topic, I'm not claiming to have invented it by any means, but what I want to talk about today is how it can be used as part of your design process. Normally when people use time and motion studies and when they think about them, they think about using them as part of to retool their construction or their manufacturing processes once the item or design has already been finalized. What I want to share today is more about how you can use them to change the design of what you're building, not just how you're building it. Hopefully today I'll share a few tips and tricks as well so that you feel empowered to go and do this yourself. But as always, if you have any problems, you know to give us a call. Now before I dive into too many more details, I just want to give a little bit of background about Home Solutions for those that aren't familiar with us. So we are a product testing and research and development company headquartered down in New Zealand. And we kind of work in three main sectors. The first is our transportation sector. So we crash over 100 cars a year to prove out the design and compliance of roadside safety barriers. In addition to the videos you see where we're flipping cars and trucks, we're involved in a whole bunch of simulation and computer modeling, as well as the amazing testing that we do here at our impact facility. We also do a lot of work designing protection systems for marine snapback events, which are quite often fatal. And finally, we've developed a new transportation technology that enables people to have rapid user transport. The second part is our recreation work. So we started a lot of our work in this by creating the True Blue product family, which is a climbing auto belay device. We have then expanded to do a whole bunch of other work, including developing the Switchback product family, which is a really awesome zip line that enables you to not only go around corners, but also up as well as downhill. And we do a whole bunch of additional ride design and development for our clients, both across New Zealand and around the world. Now the final piece that I'm going to talk primarily on today is of course related to our work in the construction industry. Now this is about 40% of our work, and I will talk about the time and motion testing obviously, but in addition to that, we have a whole bunch of test equipment that we use to do all sorts of testing. Now that can be really prescriptive testing, such as that on our shake table and our fire furnace and all our universal test machines. But what we also do really well is our research and development testing. So those are areas where the testing is really complicated. Maybe there's not even a standard to test to, but you're trying to figure out how something performs and how to continue to change the design to improve their performance. And that's where we really excel. Now these sectors seem a little bit eclectic at first, but they have a few things in common. First and foremost is they're all industries where life safety is critical. And therefore compliance is a really big factor. And that means that often the engineering is really, really complex, and so they can be slower to innovate. And it's the combination of all of those factors that was where we find our sweet spot. Our testing lab is the core of everything that we do. So it's 45,000 square feet and it's down in Christchurch, New Zealand. And in here we have basically everything you need to make or break something. And so in addition to our testing capabilities, we have so much more from our CNC, 3D printing, woodworking, metalworking that enables us to really rapidly prototype the stuff that we're designing and testing. And our team is a split between engineers from all walks of life, but also test technicians and master craftsmen that enable us to really do that rapid prototyping, to understand the practical applications of what we're doing, and to come up with really creative designs. And although our lab is based down in New Zealand, we are an internationally accredited lab, and we do work with clients all around the world. It's part of the reason why I'm based up in the US is we have a number of large companies throughout the world, but particularly in the US, that we work with regularly. So back to time and motion. I'm just going to go through a few fundamentals. I know people are familiar with it, but I want to make sure we're all on the same page. And that is, first and foremost, it's a test. It was born out of lean manufacturing, so looking at how we can build more effectively, more leanly. And it's a test where you have people, or maybe robots, running through a series of tasks while you collect data on it. And it is a process to quantify that motion. However, it's not just the motion of the people, but it's also the motion of their equipment, any other material, and all the things that are coming together because you're assembling it or constructing it. often you're collecting both quantitative and qualitative data. Now, time is the big one, but you could also be capturing the steps, the distance traveled, the equipment used, the number of mistakes that were made, or how easy it was to collaborate, and potentially safety concerns. And you're using it to compare and improve. So the value of a time and motion study is often not on the single data point you generate, because if you're simulating something, whether that be in a lab or on a construction site, it's not often always going to be a perfect replica for the final thing. So what you're actually wanting to do is look at how, when you change one thing, how that impacts that time, and it becomes a relative process, and you use it as part of a compare and improve cycle in the product design process. Who could use it? We think pretty much anyone. We see a lot of people that are designers looking to make their products and systems better designed. We also see contractors that, yes, admittedly, they might have a design that there's not much they can change about, but they're looking at how they can make their process better and how they can feed some feedback back to the designers for future iterations. You see manufacturers and also for owners and occupiers that have larger portfolios. And why use it? It helps you to define the total cost. So when you're making purchasing decisions, it's really easy to understand what the sticker or ticket price is going to be for something. But in the construction industry, the actual cost of something is going to be not only how much it costs to purchase it, but how much it costs you and your team to install it in terms of the time and any additional impacts. It's quite hard to quantify that until you start using time and motion studies, which give you that information. It was born out of Lean, so it helps to eliminate waste. And that could be waste in terms of less time used or less material. But it could also be other things like steps and processes that you could identify that could be cut out. Maybe you've got a single cut of gypsum that you keep making again and again in the field, and thinking about how you could either, use that piece of material, incorporate it into your design, or do something different so you don't have to keep using that step. It enables you to make better decisions, as we were talking about with the total cost, but also when we think back to the SRL test, it enables us to make sure that we're making good decisions about the designs we're doing so that we're getting a product at the end. And it enables us to test and verify and iterate. Those who are more involved in the product design process will be pretty familiar, I think, with this concept, even if the image is a little different. And it's about talking about who casts the biggest shadow when you're doing product design. If you're using a time and motion study on a design that's already been finalized, well, then you're sort of tinkering around with the last 15%, that labor at the end of the site, because there's only so much you can change at that point. If you're a product designer, you have so much impact on how much time it's going to take for you to install this process. And with the construction industry being the way it is, we're always going to have people on site that need to build these things, and we need to be thinking about how we can make their life easier with the least amount of effort. And that comes from that product design process, which is why doing time and motion studies at that part is so much more valuable. So now I'm going to dive into the how a bit more by using a few case studies to sort of illustrate a few different ideas. Now, the first study that I'm going to talk about is one where we were designing a concrete connector, and it was designed to be easier to install. Now, a client was trying to get it substituted into an existing building, but they weren't making a lot of progress. The contractor was a little bit nervous about substituting something that was new and only recently to market compared to something that they were more familiar with. It also came with a relatively comparable price tag, so you think about the cost of change for that contractor, it's kind of hard to quantify, and they weren't sure if it was worth doing it. Now, during this design process, we've done a number of time and motion studies, so we were pretty confident in how it was going to stack up against competitors, but we decided to help them by doing it again a little bit more structured. And so what we did is we took connection A, which was the connection that the structural engineer had designed for that building. They'd already specified it, and that was what the contractor intended to use. We then also got connector B, which was another one that was on the market with a similar price tag to make sure that we had another data point. And then we took the one that we'd helped design, which was connection C, and we ran a time and motion study. And what we did is we got them to look at, we simulated installations that were a little different. We used different installers, and we collected a bunch of data points and then took the average, as well as considering all the different outliers to see how they all compared. Now, it doesn't look like much when you're looking at it at a minute by minute basis. A few minutes here and there doesn't seem like it's going to have that much of an impact. But we were looking at substituting this connector into a building that had 57 floors worth of connectors. And so when we took that sort of time and motion data and said, okay, well, what does that mean if we have one person on site for 8 hours a day and their only job is these connections? That means for connection A, you're going to look at nearly 100 days worth of that person's time compared to a relative 47 or 21, which starts to sound pretty compelling. The other thing that was really worth noting is this was actually part of the building's critical path for a small portion of the project. And so by changing out these connections, you were ending up with a 15% program savings, which ends up having so much more value than just the cost of a few connectors. So here was a really good example of how you could use this data to make better decisions, because you could understand the total product cost of what those decisions were going to be. Another place where we've found these studies to be really, really impactful is in data center installation. Now, anyone that's worked on data centers will know that time is money, and it's basically everything to those clients. They want them built as fast as possible because of the huge value that comes to them as soon as they are opened. And so we've done some work looking at how we can impact the design to make it faster to install, to make it easier to install. And there's a few little components that we've changed because of that. I could talk about that today, but actually what I want to focus on is some of the more qualitative components. And so this is a couple of photos that aren't from the data center work, mainly because it's pretty confidential, as you can imagine, but it illustrates the point from a different homes project of how important and impactful working at height can be. So with these data centers, there's a lot of services and MEP that's sort of situated up high in the ceilings. And so when you're installing them, if they're up high when you're doing that installation, you spend a lot of time working at height. And what we did as part of this, one of these time and motion studies, is we actually measured how much time was spent by people in scissor lifts going up and down. We didn't look at the time spent working at height, we did separately, but we looked at just how much time was wasted in going up and down, or moving across and then going back up again. And it was absolutely incredible. And we looked at categorizing those in terms of how much time was spent, like necessarily, how much time they had to come back down because they'd forgotten something. And we kind of added it all up and showed the difference between if you could move some of that work so it could be done at ground level, how much time you were able to save. One of the interesting things is we also looked at the value of collaboration when you're working down low versus up high. And so when we pulled this team together to do the time and motion study, we made sure that there was a really good mix of people involved. So it's quite tempting when you're doing these studies to think about putting your best and brightest on there, but we tried to make sure we had a really good mix with different experiences from the industry. So we had a couple of really senior staff, a couple of intermediate, and a couple of newer or more junior people on there. And what we really noticed is when we had them doing the option that had them working at height a lot more, it was really challenging for them to collaborate. When they were trying to demonstrate to their younger team members how to do something that they weren't familiar with, or to point out any errors, they were sort of having to shout across space, or worse, come all the way down, go all the way across, go up again, and then repeat it and go back, which is painful, but in some cases it was actually hard if they actually had things that they were supporting up at height. And in one instance, it actually led to a mistake being made where they were sort of shouting the direction across. The person who was interpreting it interpreted it wrong, installed what they were installing incorrectly, and then that had to be picked up and remediated later on. So some of these things can be just so impactful when you're starting to tell the story and how you're trying to make design decisions, because initially it looked like trying to move all this work down to the ground level was going to create a lot more work for the designers. It was going to maybe potentially have more material impacts. But then when we started to look at the value that it was going to create for the team, it became a little bit of a no-brainer when it became to a decision. And my final case study today is to do with some of the work that we've been doing in mass timber. Now, we were asked a few years ago to help quantify how long it took to install many of the standard mass timber connectors that were available on the market. Our client had been perhaps struggling to achieve some of the installation goals that they had and that were promised by moving to mass timber. And so they were trying to figure out why that was, but also what decisions that they could make that would then help their teams in the field do this installation easier. And so we ordered a whole bunch and we started doing simulated installations in our lab. You can see we were a bit clever with some of the steel, using that to sort of reduce the amount of mass timber we needed to purchase by using steel that we already had in the lab. And what was really interesting is that these connectors are about $300 each, and they require a large number of screws at either end, and each of those screws was around 30 seconds to drill in. And that's okay because it wasn't necessarily needing to be done while these elements or the beam was on the crane hook time. But we still started to look at how challenging these were because they were really highly manufactured and they were fantastic in terms of an engineering load path, but they hadn't quite been thought about holistically and how that would be impacted for installation challenges. And so one of the things we actually did with these time and motion videos is we simulated moving that column in an inch or out an inch or 25 mils. So we kept moving it in and out to understand what that then did to the installation speed. And what we found is that it had a huge impact. So the installation time for this connector was 17 to 18 minutes. We could see that double or even triple when we started to build in what we would consider fairly real world tolerances. So we set out to design some new ones. And so we went right back to the basics to figure out how we could design it better to actually be easier to install on site. So we started going back down even to the screw level. So looking at, okay, if we had a fully threaded or a partially threaded screw, what did that do to not only the load capacity, but also the installation time? And how could we get the most capacity out for the least installation time? And then we ended up going on quite a process, but developing these connectors that really held true to this concept of crane hook time of seconds and not minutes. And so this is a really, really early prototype of it. And we were just playing around to see that we were actually achieving what our goal was. So a time and motion study can be more formal, or it can be as simple as something like this, where you're just running a bit of a clock, you're checking that you can meet the tolerances and the objectives you want without needing to do too much setup. So I'm going to run through a few do's and don'ts of things that we've learned along on the way, and hopefully they'll be useful so you don't make the same mistakes. Going back to this video that I showed earlier, this was the basic setup for that test. You can sort of see on the left we have the workers that are going to do the study, and then on the right in the orange vest is our observer. Now cameras are really important to use during studies because they help jog your memory, they help provide sort of the reporting tool or the visuals, but the most valuable thing is actually that observer. There's some really cool AI tools and all of that you can use to track tasks and do that sort of data processing for you. But the observer is the one that's really going to start to glean a lot of the insights. So making sure that they're in a position where they can see everything that's going on, even if it's a longer study that steps through processes, is really critical. You'll see they've got their notes and their clipboard and everything set up. Also, when it comes to using the cameras, we highly recommend putting pieces of tape on the floor because there's nothing worse than coming back the next day, setting up the study and then going to look at the two videos and realizing that you've just moved your camera over by half a meter and now all your videos are wonky and you need to repeat them. Another thing that's really worth thinking about is, of course, the lighting. You don't want to end up with videos where you can't see what's been done because that is more than a little bit painful. And for those that aren't doing it on site, but maybe in a lab like ours, thinking about what PPE will be used in the final case is really important. We don't necessarily use hard hats in our lab for most of the time, but when we're doing something that's for a construction activity, we always wear them because PPE can sometimes interfere with the process, and so you want to make sure you're being as accurate as possible. It's also good to think about how you can be clever about smart use of materials. When I showed the mass timber one before, we used our standard test rig beams and columns to help simulate, part of the mass timber to reduce the amount of mass timber we needed. In this case, we had the opposite, where we were doing a test on raised access flooring, which many of you know is not super cheap to buy. And so to simulate a larger area of floor, we actually used some mass timber that we happened to have lying around so that there was space for our team to put their tools, without having to buy, half a lab's worth of raised access flooring. So thinking about what you can use that still does a good job simulating what you need it to, without incurring too much cost is a really good way to go about it. And thinking again about the different camera angles. In this situation, we have a camera actually underneath the floor to capture what's going on there, which is actually quite hard for an observer to see, and also for the person that's doing the work. So a few takeaways to leave you all with. Be really wary of analysis paralysis. So make sure you understand the purpose of the test. It's really easy when you're testing or doing something fun to try and solve everything and to look at everything all at once, because testing is fun. But the more clear you can be on what you're trying to achieve, the better. And that's because more data is not better. If you have 10 different camera angles with 10 hours of footage, it's going to take you so much time just to go through, compile that footage, look for insights, process it, that you're probably going to really struggle to use it effectively. Likewise, if you end up with having tracked every single step of a process, then it might be really hard to wade through the amount of Excel data and notes that you have to look for those key insights. So try to make sure you don't have too much noise. Focus on what you're trying to study, what you want to get out of it, and what you're looking for. Remember all of the assumptions that you bring in. We all have them, so make sure you have a team that's got different experience and got different backgrounds, so they can point out where you might have made a fatal assumption. And it's all about the relativity. A data point from a test lab time and motion study is not going to be equal to one on the site. Likewise, one done on site on a sunny day doesn't equal a rainy day, doesn't equal a Friday. So think about how you can do your study to set it up to be as consistent as possible, and just look for the changes based on the changes you made, and try to control all the other variables. Remember the humans. So one of the best things that happens when you do time and motion studies is that you take one of our key stakeholders, which is the people that are putting these things together on site, and you bring them back into the design process. And the more you can do that, the better, because at the end of the day, they're the ones that have to put it together. So pull them in and get qualitative feedback from them. What did they like? What didn't they like? Why did they like A more than B? What would they change? All of that feedback is honestly some of the best insights that we usually get during this process. So make sure you make time for it, make sure you have the right questions, and you really pull from every single person in that team, not always just your most experienced. Think about the skill set and bias of the people that are doing the study. Again, like I said before, if you have only your most experienced people, then you're not going to get the insight that you might need of how maybe more junior or inexperienced people will handle it when they come to do it. And think about trying to collect information on ergonomics and safety. It's super valuable to make their lives easier, which is what you're really doing the study for in the first place. And it's more than the time. Think about the tool selection that you're using. Think about how you might change the design to change the tool selection. Think about access requirements. Think about all the effort and dependencies, and think about that workflow. Are you creating bottlenecks? Are you creating a dependency on one particular person or skill set? We really like the saying that without data, you're just another person with an opinion. So with that, go out. Hopefully these tips and tricks have been useful so that you can collect your own data, make better decisions. And if all else fails, reach out to us. We're here to help and answer any questions that you might have. Thank you.